The Air Force Small Business Innovation Research Program has funded many critical and commercially successful technologies. This is the story of one of them. The Air Force Small Business Innovation Research Program helped to propel a small team of engineers' technology to military and commercial applications in turbine blade diagnostics and maintenance. It's called the SmartBlend system.
The SmartBlend system is an automated machine used to measure the vibratory response of bladed discs. And it allows us to capture the vibratory fingerprint of that part, and then we can track how that part changes over time.
In modern jet engines, multiple turbine blades are manufactured as a single part called an integrated bladed rotor, or IBR. To function safely and efficiently, each blade in an IBR must vibrate within a very specific tolerance. Essentially, each blade has to be in tune.
One of the really fascinating things about these types of structures is that if you look at it, this one has 20 blades on it, and there's 20 frequencies that are almost the same, but not quite. So when it rings and vibrates, what will happen is that blades will vibrate at slightly different frequencies.
Instead of spinning the part to feel that force, we generate a force on those blades using sound. The engine hardware sits within the system and has speakers that vibrate the part, and it uses lasers then to measure how each blade is vibrating.
And that allows us to model the part and come up with prediction models of how this part would behave in the engine.
Mistuning can make an IBR more susceptible to high cycle fatigue because it concentrates vibratory stress on certain blades. Studies conducted in the early 2000s found that more than half of military gas turbine engine failures could be traced to high cycle fatigue. The Air Force needed to solve this problem for its jets in production, particularly the F-22, as well as for other advanced tactical aircraft that might be developed with a similar engine. Jerry Griffin has been studying mistuning for more than 25 years, and when the Air Force issued an SBIR topic seeking a solution, he and his team at Blade Diagnostics accepted the challenge.
With the new IVARS, if you replace the whole part, it can be very expensive, and they can cost in excess of $500,000.
These bladed discs get damaged during usage, and to repair them, you blend material away. You file off the damaged material and make the edges smooth again. Using a SmartBlend system, you can see how that damage and how that repair has changed its vibratory state. Each time the part is measured in SmartBlend, that data is collected and put into a database. That then allows us to track the vibratory state of that part over its life. So with the development of this technology, we've allowed the Air Force to collect data on these parts that has not been possible before.
SmartBlend is now part of the repair workflow at Tinker Air Force Base in Oklahoma City, where jet engines are disassembled, cleaned, inspected, and repaired. The technology is expected to result in significant cost savings. With their aerospace work solidly in hand, Blade Diagnostics Corporation has been able to modify their technology to work in other industries.
So what we have now, we're proud to say, is an SBIR successful technology transition. The first sale of our technology was to Siemens Energy. They are using our technology to look for early cracks in turbine blades in their nuclear power generation equipment worldwide.
The SBIR program has been fundamental to our whole development as a company. It allows you to work with the eventual customer. In this case, it's the Air Force. The other thing is you build up credibility with your potential customer. They learn what you can do, they can see the potential, and they interact with you and help you develop that concept.
There's no more fun that an engineer can have than to come up with an idea, develop it, and turn it into a technology that you and I can use.
SmartBlend keeps the jet turbine spinning safely and is a perfect example of how the Small Business Innovation Research Program helps the Defense Department meet its better buying power goals of controlling costs while getting effective new technologies into the hands of U.S. warfighters. Learn more at www.afsbirSTTR.com.